Cool. Hey, everyone. Can you hear me all right? I can hear me. It's kind of weird. You can hear like twice. OK, so I'm going to talk a bit about testing. And being as this is Polyhack, I thought I'd get more than one language involved and then call my talk Polyglot Testing. And it's kind of a fancy word, so it makes me feel smart. I'm Harry. I work at Highline Beta, which is kind of fun. If you want to find me on the internet, I'm Hagen, just spelled like that. Long story. Basically D&D character. The nice thing about it is that I always can get that name except on Skype, which is cool. Starting off with testing, I'm going to kind of talk about different types of testing. I don't know how many people actually write tests. That's a good number of people, but fewer people than should, unless the rest of the people aren't developers, in which case you're excused. I kind of see testing as like an unfair advantage in that I'm sure doctors wish they had a test that they could just run all the time. Every time they do something, it's just like running in the background and being like, yep, you're doing the right thing, you're doing the right thing. And we've got that ability as developers, and that's kind of neat. And I bet there's a lot of other professions that would like that too, like structural engineers who normally find out their stuff fails when a bridge collapses and kills a bunch of people. So they have to be like super careful. And we don't. We get to cheat and just run tests all of the time, and it just tells us like 3 seconds after you made a change, like, oh, yeah, that's OK, that's a good change. You haven't broken any of the stuff that you wrote like last week or last month or last year or that your colleague did that you didn't know about. So starting off kind of with unit tests, I've called this XUnit style because I'm going to talk about this in the context of JavaScript for this one, but there's lots of different languages that do this kind of test. I feel like it's the one that most people are most familiar with in that you've got some test file, you've got some setup, you've got maybe a teardown bit, you've got like a before each or a before everything, and you've got all your setup, and then you write some code and you do your tests, and it runs through and it tells you whether it's good or not. Does that sound familiar to anyone? I'm getting some nods. That's good. It's called the XUnit style because someone created it for Smalltalk, and they called it SUnit. And then someone thought that was a neat idea and copied it, I think possibly for Java or probably for something else first, and called it JUnit. And then lots of everyone basically took the first letter in the programming language and stuck it in front of unit and kept on going. And then someone ran out of, like, I don't know, JavaScript came along and was like, well, JUnit's Java, so what are we going to call it? And they went, I don't know, and called it Jest and Mocha and Chai and all of those other things. But the kind of thing that, let's get on to some of this. So this is kind of in JavaScript using Jest. This is an example test. So we've got some variable example, and we set example to a set with some things in, and I'm testing sets here because then I don't have to write any code. I just have to write tests, which is great because then I know it works because someone else wrote the code. So we're going to write a test to check that sets can contain items, and we expect our example to contain the number 5, and lo and behold, it does. And we expect it to contain ABC, and it does. And we expect it not to contain walrus, and it doesn't. So our test is good, and it passes. And that looks like this. And so we can be happy. I wrote another test, but it didn't fit on the previous slide. But on this slide, it definitely passed. So you can tell my tests are good. So these tests, you write them in the same language as you're writing the code, which is nice, because you already know that language because you wrote the code in it. You also have them separate to your code, so your code isn't kind of cluttered with all kinds of testing things that you don't want to worry about in production. So that's kind of nice. But they're kept separate, which is a bit different. And you've got to know what your program is trying to do to write these tests. Like for example, for sets here, we've got 2 tests. It can contain items, and it doesn't store duplicates. So you've got to know that a set can store things, and that doesn't store more than one of anything. Otherwise, you can't write the test. And so that kind of contrasting that, and I'm sticking with JavaScript because snapshot testing, which is the type of testing that's kind of been popularized in React. How many people use snapshot testing? Cool. OK, only a couple of people. OK, snapshot testing got really, really popular with a bunch of UI components, particularly React. And basically what you do is you say, here's my React component. When I run the test, I expect it to look like whatever it looked like last time. Which is why it's also known as golden master testing, because you've got this like golden master copy of what your output should be, and you're checking every time that you haven't changed it. It's really, really good for testing. I've got this big program, and I don't know what it does, and I haven't got any tests, and I want to make some changes to it. So I'm just going to record the output of that program after putting a bunch of inputs into it, and then I'm going to change it, and then I'm going to run all of those inputs again and check I didn't break anything by accident. In the JavaScript world, a lot of people are using it to stand in for all of the other tests because it kind of just checks that whatever you put in renders to the same thing every time, which is quite good. It does better than nothing. I don't particularly like it because it doesn't tell the person who's reading your tests anything about what you meant to happen. So if you wanted there to be something that you can click on and it does something, you can keep that working fine and switch that from a link to a button and your snapshot test will break. And then the person goes, oh, does it need to be a link? I don't know. It's now a button. It's still something clickable, but did they need it to be a link for some special reason that I don't know about? Well, I better go and find someone and ask them. And then, you or someone else who wrote the code 6 months ago gets bothered by another engineer coming over and goes, does this need to be a link? And it's like, no, it just needs to be something clicked on. Well, why didn't you say that? So I kind of, snapshot testing, great. It looks like this. And this is an example where we've got some theoretical payroll code, and the payroll code is something that never was tested, but it works. Customers are very happy with it. And we want to change it, but we don't want to break the old code because then the payroll will be wrong. So we expect calc taxes 75,000 to match snapshot, whatever that is. And it writes out a snapshot that looks like this. And then next time, we can check to make sure that calc taxes 75,000 does the same thing. And we can refactor to our heart's content, and it still looks the same. And that's really nice, because now we can write tests for code that we don't understand. But if you know what the code's meant to do, just say it in the tests and write proper tests. So slight rant over. Other types of testing. I'm going to switch languages now, because this is polyglot testing. And if I start with JavaScript, I wouldn't be able to use that title. So Ruby has this nice style of testing called Cucumber. Which is business-driven development. And business-driven development is the idea that as developers, we go and talk to people who aren't developers, which is slightly scary, but OK, I can maybe get behind this. So we'll write some specs, and we'll get people who aren't developers to tell us what the code should do. But that's tricky because they don't write code, so they can't write it in the nice, logical, regimented style that tells us exactly how the program should work. And if you put things in the slightly wrong order or use the slightly wrong phrasing, it breaks. Which is it's a nice idea. We get them to tell us how it should work, and they know how it should work because they're closer to the customer or because they're experts in accounting or something like that, which is definitely not something I'm an expert in. And then we can just take their knowledge and turn it into code, and lo and behold, we've got the solution. So that looks something like this. I'm rubbish at maths, so to do the basic maths I forgot in high school, I've got a calculator, and I want to add some stuff up, and if I enter number 5, and then I add a number 6, I should get 11. I hope that's right. And so this is quite nice. This is, obviously there's a bit of laying it out in the right format, but also it's a format that's pretty easy for anyone to write. You don't have to be a developer. You don't have to do computer science at university or go on a coding boot camp to be able to write this kind of stuff out. And if you did, or if you got this slightly wrong, it's pretty easy to fiddle around and get it adjusted right. But this obviously, there's no compiler for this or anything, so we need to write some more. So as an engineer, I can write some code to turn that into code. So I match all of these statements, and I've got these, and this is my code. And then at the end of it, I can run it, and it tests my code, even though it wasn't me that wrote the tests. It was some businessy person who knows more about maths than me. And they check that I get the right answer. And that's pretty cool. I don't have to write all the test cases now. I can just write the code and do the thing I like doing and not write the tests. And they can write the tests for me, and then I know whether I got it right, which is nice. Particularly useful when you're dealing with really complicated things, like not just calculators, but accounting, which is what I've used it on in the past. But moving on, Python. Python's got a neat little different type of testing called doc tests. Has anyone used doc tests before? I saw someone using Python. Yeah, a couple of people. OK, doc tests are pretty nice. They combine documentation and tests, which you wouldn't guess based on the name. And the nice thing is that because your documentation is right next to your code, and your tests are therefore right next to your code, you don't forget to update them as often. Whereas what I normally do is I change the code, and then I run the test, and they all fail. And then I remember that I had tests, and I have to change those too. So doc tests are pretty cool. And they look like this. So I've got a Fibonacci function. and it calculates Fibonacci numbers. And here you can see that I'm calculating, like, you've got the like 3 angle brackets, which is like, oh, that's a bit odd. What's going on there? That's what the Python like REPL, or read evaluate print loop, like the interactive prompt looks like. And so if I was using the little Python REPL, I could type in fib1 with this function loaded, and it would give me back 1, and I could type in fib6, and it would give me back 8. And all the doc tests do is they check that, okay, well, you've got something that looks like a REPL, so we'll run it in the REPL and check that the answer is whatever's on the next line. So now, if I change this code and break it, it will still run these tests. So it runs the tests, and it tells me it's trying this, and it got this. Okay, yep, that's good. Trying fib6, and it got 8. Okay, that's good. Everything's fine. Oh, main wasn't tested. Well, that's okay. I'm not going to worry about testing main. That was only so I could run the tests. That'd be a bit redundant. So 3 tests, 2 items, 3 passed, none failed. Everything is good with the world. Let's move on. But doc tests pretty cool. And then more languages. Haskell. Has anyone used Haskell? Oh, you're missing out. Haskell is a really fun language. It's like, as long as you don't want to do like any input-output or any interacting with the real world, it's great. So Haskell's got this cool thing called QuickCheck, which is like, I don't know if it's the original property-based testing thing, but it's definitely like the most well-known and the most kind of fleshed out. But there are other property-based testing tools for other languages. So if you don't like Haskell, well, you should. But if you don't like Haskell, like, there are other languages that support this kind of a thing. And what it does is, instead of saying, I want to test, so for example, with the Python example, we said fib1 should be 1 and fib6 should be 8. Well, with QuickCheck, we just say some facts about the world. So for example, I've got this function, take 5 from a list, or take a number from a list. None of you know Haskell, so I'll have to try and teach you it, which I'm not very good at because I don't know it very well myself. But take is a function. We don't have brackets in Haskell because that was fast down. It's not Lisp. It takes a number as the first parameter. So in here it's 5, several times it's 3, here it's -1, etc. And then the next argument is a list. In Haskell, strings are lists, so that's just fine. In here, lists are also lists, and they look like, arrays. So that's cool. And we've got some empty arrays, etc. So we're taking the first 5 things, in this case, from hello world, which gives us hello. We're taking the first 3 things from this list, etc. So that's how take works. And if we want to use QuickCheck on this take function, we can write something like this. And this is a property, or like list length. So if we've got a count and a list, then the length of taking that many things from that list will be that many things long. So if we take 5 things from a list, we should get 5 things back, is what I'm saying here. And we run QuickCheck against that, and it says, nope, that doesn't work, because if you take 1 thing from an empty list, you don't get anything back. And then we go, oh, yeah, okay, well, maybe I just got unlucky, let's run it again. Nope, if you take -1 thing from any kind of a list, you don't get anything back. So, okay, so prop list length doesn't work. So then we can have a think about it. And the interesting thing here is, previously, if our tests failed, probably our code is wrong or we've made a mistake in the test. Whereas here, we've got to think about it. Is our code wrong? Is take wrong? Well, no, because I didn't write take. I let the people who write Haskell do that for me, so I'm going to trust they got it right. So that must mean our invariant, our property that we're trying to test, is wrong. So evidently, my assumption that if you take count things from a list of x's, you get count things back, is wrong, because sometimes you get less than count. So let's change it a bit. If count is less than 0, then the length of take count x's is less than or equal to the absolute value of count. So if you take -5, then you get less than -5 things back. And if count is positive, then if you take that many things from the list, then you'll get at most that many things back. So this is kind of nice. If you take 5 things and there aren't 5 things to take, well, 4 is less than 5, 3 is less than 5, etc. So okay, so that works. And now we can run QuickCheck and our new property works. So is this testing everything about count? Like, could I write a take function that takes things from a list and gives us the wrong answer? Well, yes, I could. All I've got to do is make sure that it doesn't give you too many things, and this is fine. I could give you the first, like, if you say take 5 from a string or from a list or from anything, I could just give you a string of 5 A's, and this would be happy. So it's not testing in the same way, but I also didn't write any tests. I just said things that should be true. So I don't have to test all of the different exhaustive edge cases. I get it to do it for me, and you can see here it's passed 100 tests. And that's a lot more tests than I wrote in any of the other things, because I was lazy and I only wrote like 2, because that's as many as fitted on the slide. But also, anyone who's done testing will tell you they probably didn't write 100 different test cases. So it's quite nice to be able to say, I tested this thing and I got 100 different tests and it passed all of them. So that's pretty cool. So mutation testing. Mutation testing is probably my favorite kind of testing that I never really use. I haven't used it in a long while anyway. Mutation testing is like testing for your test suite. So Java made it kind of popular. It never got really very popular. Testing a test suite is normally thought of as one of those things that you don't need to worry about doing. Basically, the way it works is you take your code and you generate new versions of your code that are subtly different. For example, you might swap double ampersand into double pipe to turn an and into an or you might turn a plus plus a into a plus plus, or you might just delete a line of code, or you might turn an if something into an if true, or an if false to make sure it always happens or never happens. And now we've got a bunch of versions of our code that are the same, but buggy, probably. I don't know, maybe that line wasn't used, probably not. So now we've got a bunch of different versions of the code that are buggy, and we run your test suite against all of them. And we find out how many different versions the test suite successfully detects are buggy. And if the test suite thinks that your code passes and you just deleted half of it, or you set an if statement to true, well, either you don't need that if statement anymore, or you need more tests. It's probably more tests that you need. So here we've got some code. This is in Java, I think. And these are like kind of things that we might change. So we had a bit string that we were Boolean anding with the tap sequence. Well, now we're just going to Boolean OR it. That's going to make a difference. While it's greater than 0, well, what about while it's less than 0? Well, that's going to be odd because it's probably never less than 0 based on what this code is. But and then we've got an if statement. Let's just delete that. We don't need that around here anymore. And let's take the number bit set, and instead of incrementing it, let's decrement it. And we're not going to make all of these changes at once. We're going to make each of them in a different version. So we've now, instead of taking our original code like this, we've now got 4 different versions of our code that are all buggy in different ways. And we can see how they behave. We can see whether we can successfully kill off all of them. And if we do, great. And if we don't, well, something's gone wrong, and either write more tests or fix your code, but probably write more tests. It also gives you a good indication of whether you're covering all of your tests, whether your test cases successfully cover your code, because if your test cases don't reach there, you haven't got that bit of code covered, which is different to kind of, I don't know if anyone's used Istanbul or any of the code coverage things. Those just check to see if that line of code ran, which is great, but if it ran, but it always runs with the same, if your if loop runs but it's always a true, then you're never going to test half of the branches. Or if it's running but it's not needed. So this kind of goes one step beyond that. So yeah, so that's kind of mutation testing. What does this say? This says all of the things I just said. Cool. So yeah, so kind of wrapping up, testing is pretty varied. Unit tests, the ones I started with, are probably what I would guess most people are most familiar with, but there's a bunch of other types of testing that I've kind of gone through very briefly, and they've got different benefits. None of them are better than any of the others, none of them are worse than any of the others. If you don't know if you don't have any tests and you've got a bunch of code, Snapshot's a really quick way to get a bunch of tests. If you have to test a lot of inputs, but you don't want to write them all out by hand, and you do know a bunch of things that should be true about your code, then QuickCheck, property-based testing, really neat way of doing it. If you don't know what you're talking about and you're trying to pretend you're an accountant or a I don't know, lawyer or something like that, then actually just go get a lawyer to write your tests and then try and write code to turn that into tests. That's a pretty neat way of doing it. You might also learn something, which is kind of cool. If you struggle on your team to keep documentation up to date, well, just write tests that are documentation, and then maybe people remember to update the documentation because it'll like fail and not let them ship anything until they write it. And then if you've got really bad test coverage, then write mutation tests, like try mutation testing to find out where you're missing tests. Lots of different things you can do. Hopefully that was somewhat interesting. If you've got any questions, feel free to fire away. Yes?
You covered a lot of tasks after you're writing code. What about test-driven development? What's your thoughts on that?
Test-driven development is really neat. The business like the BDD tests, the cucumber tests in Ruby, the intention is very much to write those before you write the code. Because if you ask the person who knows, like if you don't know anything about accounting and then you write all of the code and then you go and ask an accountant how it should work, you probably needed to know that beforehand. So you probably can't write the code until you've got the expert to tell you how it should work. And if you're getting the expert to tell you how it should work, you should probably get them to write the tests straight away rather than coming back and bothering them a second time later. So that's kind of really early test-driven development, because that's get them to tell you how it works so you can write the spec rather than or write the requirements down rather than having to rather than before you write the code, you're writing them even earlier in the process. As for the other types of things, like QuickCheck doesn't really, like the property-based testing doesn't really kind of works, but it's better for small functions that you kind of very much know what it's going to do, so that's not so great for TDD. Unit tests are obviously great for TDD. Snapshot tests completely useless for TDD. You can't take a snapshot of something that doesn't exist, or if you do, it'll just happily pass because as long as you implemented the function, it doesn't care what the answer is as long as it was the same as last time. But yeah, TDD in general, I think, really potentially very valuable. It can be really useful in driving out a design. I don't reach for it all of the time. I mostly write my tests after I wrote the code, but sometimes I will write a really crappy version of the code, pardon my French, and then write tests against it, and then use that to make sure I'm not screwing it up. So hack it together and then essentially fix it once I've got it working. I find that quite useful. That's kind of I kind of see that as half TDD. But yeah, TDD definitely is a powerful way of kind of driving out what your code should look like. But I wouldn't say you need to use it all. I'm not religious about it. Some people are. Yes?
Mutation testing. Is this something that you reach for these days? And do you use it at all in JavaScript?
I haven't reached for it in a while. I haven't used it in JavaScript. I would say it's far more useful when you're building, I don't know, code for a nuclear reactor or something really critical where you want to make sure that you're testing everything. Because most of the web apps I've been working on in the last, I don't know, forever, if you missed a bit of test coverage, then your users will tell you, and they won't burn down your house to tell you. They'll just politely let you know that they're a bit annoyed. Whereas if a nuclear reactor is going wrong, you've probably got more of a problem. I would say it's definitely the code coverage tools, such as Istanbul or whatever, is probably good enough for the average web app. But if you're going beyond that and you need something beyond that, more confidence, then mutation testing is a good thing to reach for.
Thank you.
Yes?
So I'm pretty curious, I've always found it really challenging to write effective, end-to-end tests. So ignoring just the UI, I mean, are there any toolkits you might suggest that would make testing easy when you've got sort of multiple services, maybe like a Kubernetes type environment?
You said ignoring the UI.
Usually end-to-end is with UI.
Yes, yeah. For if you've got the UI and you're doing anything web-based, Cypress I found is really, really good. It's kind of the nicest experience I've had. In the past, I've used Capybara. It was painful, but once you get it working, as long as you don't touch anything, it kind of keeps working, which is nice. None of it's particularly amazing. The biggest problem with it all is, unless you're doing it in production where you know that everything's set up right, you've got an entire other infrastructure that you've got to bring up, and if you've got microservices, you've got to bring all of them up in the same way that you do in production, because otherwise you're not testing anything. And often people don't put the same level of, essentially the same level of DevOps kind of building everything up and making sure that everything is all set up and configured correctly into their test environment, because a test environment should be quick and cheap and easy. And that's not always the case. For end-to-end testing, it needs to be as close to production as possible. So I would say if you're having trouble with testing microservices end-to-end, go and find your DevOps person and get them to give you a second copy of production, and then test against that and see if that makes it easier.
And if you're the DevOps person?
Then...
If you're the DevOps person, then you try to do things to make sure it's going to work. Like, we have a database team, and we're trying to get them to do something where they can scrub prod-like data through to make sure the tests are going to do it. If you're actually a DevOps person, you're asking because you are the DevOps person. Okay.
Yeah.
It depends. It depends on how the environment's set up. But you try find pieces so you can make it more prod-like.
Okay.
Yeah.
Cool.
What she said.
It felt
Thank
really
you.
focused.
Yeah. Yeah.
Cool.
Yes.
So mutation testing is pretty cool. I'm
Yeah.
somewhat more familiar with the Ruby version of that.
Oh, okay, cool.
So mutation testing as a concept kind of has this, I don't know, to me has this idea of like, if I change a line of code, I should fail a test. Something like that, right?
Yes.
Which is a little at odds with what I see a lot of people do when they test or write code, or if I have a constant, or I have something like a string or some value, I put it into a constant and I use it in the code and I use it in the test. If I do that, obviously, and I mutation test that line, nothing will fail. I'm curious what you think about
Right,
that.
yes, I see what you mean.
'Cause
So if you're saying that, like, I want to check that if I calculate payroll for this particular value, there is, like, for whatever the, like, I don't know, like, tax-free allowance is, then, like, no tax is generated, kind of thing. And you're using a constant, a shared constant.
Error message, that
Oh, yeah,
this
that's a
error
better
message.
example.
If mutation test changes that error message, nothing fails.
Yes.
Is that a way we should be writing? Is that not?
Anytime you duplicate, like anytime you share something between what you're testing and what you're testing against, you're going to run into that risk in exactly the same way. If you imagine it wasn't mutation testing, if you imagine it was someone who can't use their editor very well and clicks and like hits backspace in the wrong space as they're like scrolling through a file, which Lord knows I've done numerous times. Like, you know, you go into the file and you click in the wrong place and there's a constant and you delete like a character from the middle of the error message. If you're using that constant in your error message in your test, it doesn't matter whether it's mutation testing or you writing the test, you're still going to pass the tests. So then writing the test to check that it matches that thing rather than matching a hard-coded string in the tests, it makes it risky. So I would lean on using the string in the test because, yeah, it's kind of, some would say, well, you can dry that up. And it's like, yeah, but you're testing. You're not trying to dry it up. You're trying to check that it's this thing. Does that make sense?
Yeah, that's I have various places in that in my mind. So
Yeah.
that's good.
Yeah, I would say try and test against explicit things, like test against, like, even if you've got like a 300-line object, like, yeah, okay, maybe move that to a separate file and import it and compare against it in your tests, but don't generate the object using the same, like, or similar code or related code to what you're testing, kind of thing. So, like, be as explicit in your tests as you need to be, because you probably shouldn't be shipping your tests to customers in a way that's going to bloat your binaries, so it doesn't matter how big it is. Like, it's all small, it's all text. Any more? Cool, thank you.